In this video, I'm going to be working a multivariable calculus quiz over the chain rule. And I think I'm just going to be working form P because form Q is very similar to this, and you probably have access to the solutions elsewhere. I'm just going to start off with this one. Yeah. Okay, so I've got w equals x to the 3 plus y to the 3, x equals sine t, and y equals cosine t, find dw dt. Yeah, I was thinking about just writing the chain rule off to the side, but I'm just going to write it each time. So, in this case, w depends on x and y, which are both depending on t. So, this is kind of... And also, they asked for dw dt, not like the partial derivative of w with respect to something. So, I'm going to say that, okay, I'm just going to analyze the contributions from x. And I'm also going to consider contributions from y. Okay. And then I'm just going to need to fill in some pieces here. Okay, so partial derivative of w with respect to x, that's going to be 3x squared. And then the partial derivative of w with respect to y is going to be 3y squared. And I am going to write those in terms of t, so that's going to be 3 sine squared t, and this is going to be 3 cosine squared t. Right, and now I'm going to need dx dt and dy dt, so x prime of t is going to equal cosine t, and y prime of t is going to equal negative sine t. And then I'm just going to fill in the pieces over here. Partial of w with respect to x, that's 3 sine squared t times another x prime, that's cosine. So 3 times 2 powers of sine times 1 power of cosine. I forgot the t. Alright, and then partial derivative of w with respect to y, that's 3 cosine squared t multiplied by y prime, so that's times negative sine t. Okay, so minus 3, 2 powers of cosine, and 1 power of sine. Alright, and that's, I'm sure we could factor a cosine and a sine out of this, but, I'm not sure exactly what that would leave us with, so I'm just going to leave that there. That's going to be a suitable expression for our purposes. Okay, over here, we've got w equaling 2e to the x plus y, where x and y depend on both s and t. So this is going to be, okay, 2 layers, 2 variables each. So I'm going to say I'm interested in the partial derivative of w with respect to t. And that's going to be, alright, well, in the middle I've got x and y, so contributions from x and contributions from y. Partial derivative of w with respect to x times partial derivative of x with respect to t. Okay, that'll be 0. That's nice. Plus, okay, from y, I'm going to have partial w with respect to y times partial derivative of y with respect to t. And so then I'll have... that's equaling, well, it doesn't even matter what wx is because the partial derivative of x with respect to t is going to be 0 because there's no t in the formula there. Okay, so I need w with respect to y. And e to the thing is its own derivative, but we might need to multiply by the derivative of x plus y with respect to y. That's just going to be 1. Alright, so that's 2e to the x plus y. And then I'm multiplying by partial derivative of y with respect to t, and that's going to be 2t. And then I'm just going to say, all right, well, find the value of dw dt. Oh, yeah. All right, so 2e to the x plus y times 2t. Okay, well, we've got the value of t, but we don't have x and y, but we can calculate those using the formulas that they gave us. So I'm going to say that this is 2e to the, okay, x of 2 and 1 is going to be s to the third, where 2 is the s, so that's going to be 8, and y, where s is 2 and t is 1, is going to be t squared, that's going to be 1. Alright, so 2e to the 8 plus 1 multiplied by 2t, so that's 2 times 1, and so that would be 4e to the 9. Right, now we've got z equaling e to the x cosine y. Let x and y be functions of s and t. Okay. All of this stuff here. Find the value of partial of z with respect to s. All right, we can do that. So partial of z with respect to s is going to equal, all right, I've got x and y is what z is depending on, so contributions from x plus contributions from y. With respect to s. All right, and so I've got kind of all the pieces here. So partial of x with respect to s is 3. Go there. And partial of y with respect to s is 4. I'll go here. So I just need to take the partial derivatives of z with respect to x and y. So zx equals, well, a cosine y is a constant. So if I was taking the derivative of 5e to the x, that would be 5e to the x. So this thing is going to be its own derivative, e to the x cosine y. And then with respect to y, I'll be taking the derivative of cosine, and that's negative sine, so negative e to the x sine y. Right, and I might figure out what those are going to be. Okay, so what this is saying is x equals 0 and y equals 0, so I'm going to use those. So that's going to be e to the 0 is 1, cosine of 0 is also 1, there we go, and then e to the 0 times sine of 0 is 0, so, alright, I've got zx equaling 1 and zy equaling 0, so that'd be 1 of these and 0 of those, so that's going to equal 3. We've got one that's 3 input variables for w, and then each of those depend on one input variable t. This is like a parametrized curve type situation, is where this would come up in the future. So dw dt. Okay, I'm going to have contributions from x, y, and z. So partial derivative of w with respect to x times dx dt plus partial derivative of w with respect to y times dy dt, and then partial derivative of w with respect to z multiplied by dz dt. I see that dz dt is going to equal 1, so I'm going to start with that. Okay, now dy dt is going to be 2t, and t is equaling 1, so I'm going to have 2 there. And then dx dt would be 3t squared. I'd plug in a t equals 1, and I would have 3 there. Okay, now I'm going to have to take the partial derivatives, because I don't think I can do those mentally. So wx is going to equal y squared z plus 0. wy is going to equal 2xy to the first z plus z squared. And then wz is going to equal xy squared plus 2yz. All right, and then, okay, at t equals 1, x, y, and z are all equaling 1. So I'm thinking, it's like, look at this formula and think of x, y, and z as all a bunch of 1s. So I'm going to have 1 plus 0 equaling 1, 2 plus 1 is equaling 3, and 1 plus 2 is also equaling 3. All right, so wx equals 1, wy equaled 3, and wz also equaled 3. And then I'm going to have 3 plus 6 is 9, plus 3 more is going to be 12. I think this is going to be the last one. So z equals log of 2x squared plus y. Let x and y both be functions of t, with this stuff going on here. Find z prime of 1. All right, z prime of 1, that's like saying dz dt at t equals 1. And so, that's a hint that we're going to use the simpler chain rule formula. So z is depending on x and y, which both depend on just the one input. So partial derivative, I mean, not partial, derivative of z with respect to t is going to equal partial derivative of z with respect to x times dx dt plus partial derivative of z with respect to y multiplied by dy dt. Okay, and so I'm going to need those partials because I've got x, y, and y prime. It's kind of like listed off to the side. So zx, okay, derivative of natural log is 1 over that. So that's 2x squared plus y, and then I take the derivative of the inside with respect to x, and I would get a 4x right there. And then zy is going to be, okay, derivative of natural log is 1 over that thing, 2x squared plus y, and I take the derivative of the inside with respect to y, and I'm just going to get 1. All right. Now, when I plug in x equals 1 and y equals 2, I'm going to have 4 over 2 plus 2, and that's looking like 1 to me. And zy will equal, I got the same denominator, so that's going to be 1 over 4. So I'll say this thing I'm looking for is going to be zx, which we determined was going to be 4 over 4, times dx dt is x prime of t, that's x prime of 1, that's going to be 3, plus partial derivative of z with respect to y is a fourth, multiplied by dy dt is 4, so that's going to be 3 plus 1, and that's going to equal 4. All right. Yeah, I think I'm just going to stop here because the ones on Form Q are exactly the same. They just got different numbers. So that's going to be all for this video. Thanks for watching.